uh, and then buildup of solid depositions. So the buildup of wax, scale, hydrate, asphaltene, sand. This is also an important issue for us because uh, due to temperature gradients. So this our oil is temperatures are low and the flow is unprocessed well stream. So due to these conditions like low temperature and pressure, like there will be solid depositions, mm, like I said, wax, scale, hydrate depositions. And it's also important issue because like when these things form, they are formed from the fluid, right? And so we lose like we can't deliver a proper flow, and we lose substance. Next one, corrosion. It was mentioned. So we move to our next topic. It's corrosion. So what is corrosion? Yes. Pardon? Yeah. Right. Corrosion is the process of decay on a material caused by a chemical reaction with its environment. The reaction is usually oxidation. So next, like before the next question, I want to ask: when we say corrosion, we usually think of metals, but does it always happen to metals? Can you answer? Does corrosion? Okay. Pardon? Yeah, right. Like, I mean, does it happen to anything other than metals? That's my question. Yes, no, yes, no. Actually, the answer is yes. It happens to things like even like plastics. But usually we usually think of metals because that's the most common issue for us. So when does it happen? When does corrosion happen? Like what are the conditions for corrosion? Like whatever comes to your mind. Yes? Yeah, right. Anything else? Okay. Corrosion of metal occurs when an exposed surface comes in contact with gas or liquid, and the process is accelerated by exposure to conditions like warm temperatures, acids, and salts. So, like there are now two groups: classification and types. Like, can you name me the classifications and types? Like first classification. Like if it seems a bit vague, I'm gonna give you a hint that classification is related to the medium of the corrosion. So can you now, after this hint, can you name me the classifications? Okay, Statue of Liberty. It obviously has corrosion, right? Where what is it exposed to? Statue of Liberty. Like the answer is more basic, like air, right? Like so, the first category is atmospheric corrosion. So if we have atmospheric, then we have yeah, right, aqueous. So we've mentioned that the challenge for our subsea production systems, one of the problems was corrosion. So if we have atmospheric corrosion classification, then we have aqueous marine corrosion. And what about the last one? Like so, we have air, water. What is left? Pardon? Soil? Uh, uh, I said the answer actually. Yeah, soil. So, for example, archaeologists find bullets in the places of battles, right? So usually they are not like perfectly as they don't look perfect, right? So they have corrosion. So corrosion also happens in the soil. So these were our classifications. Now, what about the types? Anything, any type of corrosion that comes to your mind? uh, it's like two, bro. Like most of the corrosion is oxidation, right? General attack corrosion, like it's like general corrosion, like corrosion happens to the whole body, solid substance. If we have general attack, then like this is for the whole body, right? Then we also should have what? Yeah, well, localized. Localized. So like there are three types of localized corrosion. These are pitting, crevice corrosion, and filiform corrosion. Pitting happens when there is a hole, small hole in the metal, and the corrosion breaches the metal and starts to spread and deteriorates the properties and causes crackings and whatever. What else? Crevice corrosion frequently happens in the stagnant microenvironment, like under under beneath the gasket or clamps, and can be caused by acidity or oxygen depletion inside the crevice. And the third one is filiform. This happens when water breaches the coating of the metal, and then the corrosion uh, and and then it spreads. This usually happens when there are flows in coatings of the metals. Next, galvanic. Can you explain me this kind of corrosion? What is galvanic corrosion? Any suggestion? No? Okay. So the two separate metals are placed in electrolyte, corrosive, in the medium of corrosive electrolyte. So what happens is that this creates a galvanic couple between the metals, and so one metal is now cathode and the other one is anode. So now I'm gonna say one thing. It's that uh, the metal that is now the anode corrodes quickly, while the cathode corrodes slowly. Like it's the opposite. In the cathode, like there is like almost like no corrosion. What is the reason for that? Like why corrosion is stronger in anode, and on the cathode it doesn't really happen? Like yes, right. Like the oxidation in galvanic cells, the oxidation reaction happens on the electrolyte, on the electrode, which is anode, right? So, and by definition, corrosion was like due to uh, oxidation reactions. So, by logic, on the anode, corrosion should be much stronger. Next one is environmental. So, environmental corrosion is due to environmental factors like uh, temperature, uh, chemicals, and stress. Next one, flow assisted. What is flow assisted corrosion? What is the most common flow in nature for us? And the two types of flows: wind and water, right? So wind and water, they dissolve the protective oxide layer on the metal, and then they start the corrosion starts inside the metal. Next one is intergranular. Can you guess what this means? Okay. Intergranular is due to the impurities in the metal, and so corrosion happens in the grain boundaries. Like this is an interesting one, dealloying. So what is dealloying? Like we have alloys, right? And in alloys, like there is a main metal and other chemical elements. So dealloying means there's no more alloy. So why does this happen? Like corrosion should attack one of the chemical elements inside the alloy. So due to this, like no more alloy. So it's still alloying. Fretting. Fretting, this one happens when there are two surfaces in contact and there is relative motion between them, and oscillator, usually vibration. So this is due to this. And high temperature corrosion. When does this happen? When do we have high temperatures? What kind of reaction, for example? Release of energy. What is the reaction that releases energy? Yeah, combustion. It happens usually during the combustion. The combustion product cause the corrosion. Okay, so how can we prevent corrosion? What are the ways to prevent corrosion? Yes? Right, right. That's like the most common, right? What else? Yes? Right, right, right. Anything more? Yes? Yeah, right. So environmental modification. This simply means changing the environment of the metal so that the to reduce unwanted chemical reactions and reduce the exposure of the surface to these conditions, like contact with limiting contact with rain or seawater. So metal selection and surface conditions. Uh, so understanding the causes of corrosion, like we talked about this here. Why did we need this? Because if we can understand the causes of corrosion, we can it can lead to for us to it can lead to selecting proper metals for the particular purpose, right? So this is metal selection and surface conditions. Like there are three ways: cathodic protection, corrosion inhibitors, and plating. Cathodic protection. What is cathodic protection? Like we would. This is an electrochemical process. This is against galvanic corrosion. So we talked about galvanic corrosion, right? Remember? So we said that on the anode there is more corrosion. So we have to obviously protect anode, right? How can we do this? Like what does cathodic protection do? Like I think the name says it. Yes? Yeah, almost. Yeah, I think yeah, you're close. Like definition of anode and cathode comes from what? What? Yeah, yeah, right. And voltage difference causes what? Current, right? So in order to protect anode, we have to create opposing current. So now the anode becomes cathode. So the corrosion doesn't happen. And the next one is corrosion inhibitors. These are chemicals that react with the surface of the metal or with the gas or liquid that is in contact with the metal. So in order to stop corrosion. And plating, it's just using metallic plating, such as electroplating, that can inhibit corrosion. And the last one is coating. It's applying paints and organic coatings in order to prevent metals from corrosive effects of environment. So I guess this one is the most popular and the easiest one that comes to our minds, right? Yeah, that's it. Thank you.